Math 102, inverse functions definition. So before we can talk about an inverse function, we have to talk about something called a one-to-one function. Now our definition is going to sound a little bit strange. It says if A is not equal to B, implies that f of A is not equal to f of B. Since that's a little hard to wrap our minds around, we usually use the horizontal line test. If you remember the vertical line test from much earlier in the semester, this will sound similar. So if every horizontal line intersects that graph, no more than 1 point, then the function is one-to-one. So on my graphs here, let's draw some horizontal lines. Now each of those intersects it only the one time, so this function, which is the linear function, that is one-to-one. What about in part B though? If I draw one right there, I just got an intersection right there and right there, so I have hit it 2 times. And I'm going to note that quadratic functions, because that is a quadratic function, are not one-to-one, and that's going to be significant for us. So now that we've seen one-to-one, let's at least talk about our definition of an inverse function. So again, my function must be one-to-one. We say then that g is the inverse of f if I can compose both directions. So both fog and goff equal x. Now our notation, it looks like f to the -1 power. We do read that as f inverse though. And we've got a few properties. That inverse function must also be one-to-one. So what that means is if we've got a quadratic, either as our question or as our answer, we've got a problem because quadratics are not one-to-one. We also say that inverse functions are symmetric about the line y equals x. And we say the domain of the original function f is the same as the range of f inverse, and the range of the original function f is the same as the domain of f inverse, because basically inverses are switching the x's and the y's.